Hi students, again welcome to another video of ECT 206 Computer Architecture and Microcontrollers. In this video we will see about the arithmetic operations. That is what we are going to see. Arithmetic operations means addition, subtraction, multiplication and division. We will see what are the instructions related to addition, subtraction, multiplication and division. Maybe in the coming two videos. So let us go to the addition operation. So the instruction for addition of unsigned numbers. There are two types of numbers, that is unsigned numbers and signed numbers. See, unsigned numbers means they will be all positive numbers. We don't have negative numbers. Sign comes when we have to represent negative numbers. So signed numbers means there can be positive and negative numbers, and we give one bit as sign bit. MSB bit, most significant bit, that is the leftmost bit, is the sign bit, and we use sign bit will be equal to 0 for positive numbers and sign bit will be equal to 1 for negative numbers. This is the common notation that we are going to use. Now here we are going to use unsigned numbers. Unsigned numbers means only positive numbers are there. So what is the instruction that we have? We have the instruction ADD, next is the destination, and next is the source. So this is a comment. What will happen when you give this instruction? Add a comma source. A, the accumulator, is equal to the present value of the accumulator plus source. And you have to remember that memory to memory arithmetic operations are never allowed in 8051. You cannot have both destination and source as memory address. So you will not get something like this: add 45H, 50H. It means that 45 and 50 are memory locations, and whatever data is in 50, you add it with the data in 45 and store the result in 45. Now this is a totally invalid instruction in 8051. Do memory to memory addition or arithmetic operations. That is the first point. Second point is this instruction, arithmetic instructions, will change the flags. You can change the auxiliary carry flag, and the parity bits of the flag register. The flag register is what we call it as PSW. That is what we saw in the last video. So arithmetic operations will change the conditional flags. Since it is unsigned operation, it can change the auxiliary carry flag and the parity flag. So this is the addition operation. Now let us do one problem. Assume that RAM locations 40 to 44 have the following values. Write a program to find the sum of the values. At the end of the program, register A should contain the low byte and register R7 should contain the high byte. All values are in X. So this is a memory location. For 40 is the address with content 7D, 41 is EB, 42 is C5, 43 is 5B, 44 is 30. So you can draw something like this. We have 5 locations. And each location has value. So 40 is 7D, 41 is EB, 42. Maybe what we draw in the class. No? C5. Next location is 43. It has 5B. And last one is 44. It has value 30. Okay. So you have to write a program to find the sum of the values, and at the end of the program A should contain the low byte. When you are adding these 5 numbers, definitely this is of 8 bits. So when we are going to add 8 bits, then definitely the answer will be 9 bits, because there will be a carry. So that carry should be in R7, should contain, register A should contain the low byte. So can you write a program using add? No, these are continuous locations. No, so you can start with 40 and then you can add 41, then add the content of 42, add the content of 43, add the content of 44. When you're adding first two numbers, if there's a carry, then you should store that in R7. Then again EB plus C5, the result of the sum of the first two numbers plus the third number. Again, if there is a carry, you are going to increment, otherwise you are going to add the next number 5B. Next, again you are going to carry is there, you will increment R7, and if carry is not there, you will add the next number. So let us see the program. See, move R0, 40, because I want to start with 40 and I want to take 41, 42, 43, 44 till 44. So there are 5 numbers. So this is the counter. So this is the pointer pointing to the first location. Locations here now. That is what is being here. Then we have 5 numbers to be added. So that is what I am here. Move R2, #5. Then I am going to clear A. Clear A means the accumulator is the where the place you should store the answer. So that should be, answer is to be loaded here. So answer location is clear. If there is any data there, that is clear. So answer location is cleared. Then move R7, A. So what will this will clear the second higher byte. Higher byte is stored in R7, and that higher byte location is also cleared. That is what we are doing. Then we have to add 5 times. So what I am doing, add A, at R0. So R0 is pointing to the location 40. So whatever data is in 40, it will get added with A. A is initially equal to 0. So 0 plus first number. Then if there is no carry, this is the function for jump if no carry. JNC stands for jump if no carry. If carry is not there. Since if carry is not there, you will jump to this location. Carry is not there, it will jump to this. If carry is there, it will come to this location. So if there is carry, it will come here. If there is no carry, it will come to next. So that is for keeping track of the carries. So no carry means it will come here. What will that do? Increment R0. So R0 becomes 41. And DJNZ R2, again DJ means decrement and jump if non-zero. Decrement and jump if non-zero. That is DJNZ. Decrement and so decrement what? Decrement R2 and jump if not so. So you are going to decrement R2. R2 is already having the value 5. So R2 becomes 4. Is it 0? No, it is still non-zero. So it will jump to again. So again is another label. It will come here. And again what will happen here? Again the instruction is, again is a label. So at this location, what is the instruction? Add a comma r0. So initially we had added a with the contents of 40. Now 40 is going to change and it is going to take 41 because now here we have incremented 40. Again, after adding, if there is a carry, it will come here. If there is no carry, it will come to the next instruction, the next label next. So here you are going to again add increment R1. So 41 becomes 42. You are going to decrement and jump if non-zero. Now R2 is going to get decremented. It is 3. It is still non-zero. So it will again jump. It will jump to again location again, where you are going to add the third number 42. If there is a carry, you will store it R7. If there is no carry, it will come to the label next, where you are going to again increment by 43. Jump if and jump. So now R2 becomes 2. Now again we are going, it is going to come back to the label again, adding again 43 is added. Carry is there to store in R7. If there is no carry, it will come to increment. So 43 becomes 44. Decrement again. R2 becomes equal to 1. Non-zero. Non-zero. So again it will come to the label again. Add with the 44. If there is carry, you will store in R7. If no carry is there, you are going to increment 45. Decrement and jump if non-zero. So now you are going to decrement. R2 becomes equal to 0. It is not non-zero, it is 0. So it will not go back. It will come to the next line, that is the end of execution. Okay. So here we are going to add 5 numbers continuously. Important type of program which is an application of add instruction. I hope it is clear for you. Please go through this program once again and learn this. Let us see another program. Write a program to add two 16-bit numbers. The numbers are 3CE7 and 3B8D hexadecimal. Place the sum in R7 and R6. R6 should have the lower byte. See, let us see this program. See, you have to remember that the size of A as well as the size of R0 etc. up to R7, this is just 8 bits. So if you want to add 16 bits to 16-bit numbers, then you should add, you can add only 8 bits at a time. So you have to do 8-bit addition 2 times. Okay. So first we will have 3C E7 and then we will have 3B8D. So first what will we do? We cannot add these two numbers together. So first we will add this 2. And you will get the answer here. So D plus 7 is E, F, 0, 1, 2, 3, 4. So there will be always a carry to this one. So E plus 1 is F, F plus 8, 0, 1, 2, 3, 4, 5, 6, 7. 7, you get the answer 74. And then you are going to add the, so here there will be a carry. So with the carry you are going to add. So next addition part is the addition of 3C plus 3B plus 1. That is what we are going to add. So that will give you 78. So let us see the program. We will clear the carry flag. Maybe all the location where you have to store the result you can clear. So not only this, you can clear also R7, R6, etc. You can clear because all that location you're going to carry. First you will move E7 to accumulator and then you will add accumulator comma 8D. So already accumulator has E7 will be added and the result will be stored in accumulator. And that answer you have to store in R6 because it is given R6 should have the lower byte. So this part you will store in R6. The upper part you have to store in R7. Now you have to move the second one. So second part is moving the accumulator with the 3C, this part. Then you have this instruction ADDC. So ADDC means add with carry. Means add with carry. So whatever value is there in the carry flag, that will be added with the source and destination. So here you will have 3B plus 3C plus 1, which is 78 in hexadecimal. So ADDC A comma 3B H. So already A will have 3C plus 3B plus carry. It will be added. And the result we have to store in R7. So that is this step, move R7 comma A. So here we learned about add with carry, ADDC. Whenever we have to consider carry also, we have to use ADDC. In the previous problem, we didn't do ADDC because it was just 8-bit addition. So 8-bit addition, 5 8-bit numbers we were adding. So there carry to the 9th bit which we want to store. But here this is not the case. Here we said 16-bit addition. So we have to divide the 16-bit number into two 8-bit number and add. In that case, there can be a carry from the 8th bit to the 9th bit because it is 16-bit now, 8th bit to 9th bit. In that case, we have to consider the carry. We have to add with the carry. That is why we use ADDC. I hope it is clear. So please practice this, these two important problems. The next addition that we are going to see is a special type of addition, that is dealing with BCD numbers. So BCD means it is binary coded decimal. So this is an important topic because this has a special function. So please listen carefully. See, in binary coded decimal means each decimal will be coded by the binary number. That is, if you have 27 in decimal, it will be written as, see, you will write the binary of 2 and then you will write the binary of 7. So binary of 2 is 0, 0, 1, 0 and binary of 7 1, 1. So this is binary coded decimal. Use 27 in 10. We will write it binary as, how can you write it in binary? It is 16 plus 8, 840 2 and 1. This is the answer in binary. But in binary coded, it is different. See, this will have the place value. Hope you remember place value. 2 raised to 0, 2 raised to 1, 2 raised to 2, it is not there. 2 raised to 3, and this is 2 raised to 4. 2 2s are 4, 2s are 8, 2s are 16, plus 2 2s are 4, 2s are 8, plus 2 raised to 1 is 2 plus 1. So 16 plus 8, 24, 25, 26, 27. This is the binary representation. And this is the binary coded decimal representation. Okay, so please understand this. Binary coded decimal, binary representation. These are two different representations. Okay, so maybe 100. How can you write 100? 100 we will write it as binary. Then we will have binary of 0. And then we will have binary of 0. So binary of 1, we will write it as 4-digit number. Binary of 0 and binary of 0. This is how you write it in BCD notation. So understand that in BCD only 0 to 9 is there. Other symbols. You don't have A, B, C, D, E, F. We don't have these symbols. These are not used in BCD. These are not used in BCD. In BCD, only 0 to 9 is there. Now, so these are the symbols in BCD. We have written here. Now, what is unpacked BCD? See, in unpacked BCD, the number will be represented as an 8-bit number, and the upper nibble will be all 0, and the lower nibble will represent the BCD for 9. So upper will be all 0, lower part will be 9, 1, 0, 0. So 49 means, how will you write in unpacked form? Unpacked form means you will write 0, 0, 0, 0, then you will write 4, that is 0, 1, 0, 0. Then we have 9, 0, 0, 0, 0, and 9 will have 1, 0, 0. So this is the unpacked form. So it is totally, you can find 16 bits. And another format is there, it is the packed format. So in packed format, each bit will take 4 bits. So 59 you can see now, we have 5 and 9. In unpacked form, you will write it as 0, 5, 0, 9. So here you can see it will take only 1 byte. But if it is unpacked form, it will take 2 bytes. So that is the difference. It will be more compact. Compact. So it will be compact. A packed form will be always compact. Now, the importance of BCD. We want to add these two numbers, 17 plus 28. Okay. Let us do it in binary forms. 1 means 0, 0, 0, 1. 7 means 0, 1, 1, 1. 2 means 0, 0, 1, 0. 8 means 1, 0, 0, 0. I am going to add these two numbers. So it will become 1, 1 plus 0, 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 1 plus 0 plus 1, 0 plus 0, 0 plus 0. So if I write it as hexadecimal number, this is 3 and this is F in hexadecimal. Okay. Now let's see. See, your answer is 3FH, which is not a BCD number. Which is not a BCD number. Because why? F is not a BCD symbol. CD has only numbers from 0 to 9. So F is there. So this is not a valid number. Now how can you correct it? To correct it, what we have to do is, for each nibble, if you want a correction in each nibble, you have to add 6. So to each nibble, you have to add 6. So if it is lower nibble, you have to add 6. If it is upper nibble, you will add 60. Because upper part you will have to add 6. Lower part you have to add 0. So if it is upper part, we will add 60. Let us add and see 3F. We have 3F here. Let us add plus 6 since it's an invalid number. So F plus 6 is 0, 1, 2, 3, 4, 5. Okay, so carry will be there. 3 plus 1, 45. Can you see that? 17 plus 28. What is it actually? 7 plus 8 is 5. 2 plus 1 is 7 plus 8 is 15. 5. So 7 plus 8 is 15. Carry 1. 2 plus 1, 3 plus 1, 4. 45. So this is the correct answer which we get here. So to get the correct answer in BCD addition, we have to add 6 to the lower byte, and similarly if it is in the upper byte, we have to add 60. I have given another example, 52H plus 87H. So let's see, 52 plus 87. Actually you have to get 7 plus 2, 9, 8, 9, 10, 11, 12, 13. So you have to get 139. Let us see, 5 is 0, 4, 5. 2 is 0, 0, 1, 0. 8 is 1, 0, 0, 0. 7 is 0, 1, 1, 1. We are going to add it. 0 plus 1 is 1. 1 plus 1 is 0. Carry 1. So 1 plus 1 is 0. Carry 1. 1 plus 0 plus 0 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 1 is 1. Let us write the hexadecimal notation. This is 8 plus 1, 9. And this is 8, 9, 10, 11, 12, 13. So A, B, C, D. Right? A10, B11, C12, D is 13. So the answer is D9, which is invalid. It is an invalid BCD. The upper nibble is not correct. So what we should do? To D9 we should add 60. So 9. What is D plus 6? D plus 6 is E, F, 0, 1, 2, 3. So D plus 6 is 13. So 139, which is the valid result which we want. So this is called BCD addition. So in BCD addition, after addition, normal addition, if it is not a valid BCD number, we add 6 to the lower nibble or 60 to the, depending upon which is the wrong BCD number. Okay. In 8051, in 8051, this correction in BCD number is done automatically by an instruction, and that instruction is the DA instruction. So the syntax of DA instruction comes like this. The instruction is DA, and after that A. This is our operand, and this DA stands for decimal adjust. Decimal adjust for BCD addition. So if you are asked to do BCD addition, definitely you have to use DA instruction, and the syntax is DA comma DA space A. So it will work on the accumulator. So if you want to do the decimal adjust for BCD addition, your result should be in the accumulator. So here I have given a small example. See, move A comma hash 47, that is my first operand. The second operand is move B comma hash 25. I want to add these two numbers. I am doing BCD addition. So I am add A comma B. So it will add A becomes A plus B. So your answer is in the accumulator. Now 47 plus 25, what happens is 0, 1, 0, 0, 7 is 0, 1, 1, 1, 2 is 0, 0, 1, 0, 5 is 0, 1, 0, 1. Have to add it. 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1, 1 plus 1 plus 1 is 1, carry 1, and this is 1, this is 0, 1, 1, 0. So this is 4, 5, 6, and this is 8, 9, 10, 11, 12. So 12 is C. Now this is invalid. So you should add 6. 6 C plus 6 should be added. So C plus 6 is C, D, E, F, 0, 1, 2. Carry 1, 6 plus 1 is 72. What is the add these two numbers? 7 plus 5, 7, 8, 9, 10, 11, 12. 4, 5, 6, 72 is the expected answer. And when we do this correction, it is 72. In 8051, you need not do the 6 addition and all. What you need to do is, after the add, you just do DAA. So it will automatically adjust and give the answer as 72. So this is the importance of DA instruction. It is decimal adjust for BCD addition. So this is used for BCD correction. An invalid BCD has to be corrected, and this is done by giving DA instruction after add. Add ചെയ്തതിനു ശേഷം അടുത്ത instruction ആയിട്ട് DAA ആണ്. So the operand will be always in the accumulator. Accumulator എന്ത് വാല്യൂ ആണോ ആ വാല്യൂവിനാണ് BCD addition decimal adjust ചെയ്യാനായിട്ട് പോകും. So this is an important instruction. So please study it, understand it. See, now we will see the instruction for subtraction, and this is subtraction of unsigned numbers. I told you. So this is just some positive numbers. Sign is given for negative numbers. So It is not signed numbers, unsigned numbers. So it is just positive numbers. Now what is the instruction for subtraction? This instruction for subtraction is SUBB. Remember, SUB, two B's are there. So the second B stands for borrow. Subtract with borrow. Okay. So addition you will always get carry, but in subtraction you will have borrow. So borrow is also indicated by the carry flag. So in subtraction operation, carry flag indicates the borrow. So the syntax is SUBB A comma source. So what has happened? A is equal to A minus source minus CV. Very, very important. Subtraction means A minus source minus the carry flag. Okay. Now there are two cases for SUBB instruction. One case where carry is equal to 0. Another case when carry is equal to 1. So you have to understand that in 8051 there is no separate circuit for subtraction. Adder itself acts as the subtraction. So how will you do it? When Cy is equal to 0, when Cy is equal to 0, what is A? A is equal to A minus source. So what it will do is, it will do A plus minus source. That is, the second operand will be represented as a negative number. Negative number is always represented by the 2's complement. So the second number which is in the source will take the 2's complement of it and add it with A. So this is how you are going to do the subtraction. The steps of hardware of the CPU in executing the SUBB instruction is, see, take the 2's complement of subtrahend. The source, subtrahend is the source. So you are taking the 2's complement, add it to the minuend. Minuend will be always in the, so you are going to do A plus this minuend, and then what you are going to do is you are going to invert the carry. So if you take carry, then you will Cy equal to 1, you will make it as 0. If you get Cy is equal to 0, you will invert the carry after this operation and carry will become equal to 1. So this is how you are going to do the, this is how it is, subtraction is done inside the 805. Let us do an example. Let us do subtraction of 3f and 23. So when we see, we have to do 3f minus 23 means what we will do? 3f plus minus 23. That means we will take the 2's complement of 23. So what is 3f? 3f is 0, 0, 1, 1. F is 1, 1, 1. And 23 is 0, 0, 1, 0. 3 is 0, 0, 1, 1. Now we have to take the complement. So how do you find 2's complement? First you find 1's complement. So 1's complement means just inverting. 0 becomes, so inverting. Then you will going to add 1. So plus 1 you are going to. So you will get it as 1, 0, 1, 1, 1, 0, 1, 1, and the carry is 0. So what you are getting? This answer that you get is 1101. Okay, sorry. This is, we got this. Now what you have to do is we have to add this number and this number. They have to be added. That is how you get. So 1 plus 1 is 0, carry 1. 1 plus 1 plus 0 is 0, carry 1. 1 plus 1 is 1 0, plus 1 is 1 1. So 1 1. 1 plus 1 is again 1 0, plus 1 is 1, carry here. 1 plus 1 plus 1, again it is 1, carry 1. 1 plus 1 plus 0, it is carry 1. Now 1 plus 0 plus 1 is 0, carry 1. 1 plus 0 plus 1, it is 0, carry 1. Now this is the carry. Now what is your answer? This you got it as 1. This is 8 plus 4, 12. So 12 is ABC. So 3F minus 23 is 1C. Now what you have to do? This has to be inverted. The carry has to be inverted. So carry has to be inverted means Cy will be equal to 0. So this will be automatically done. This, when you are doing SUBB, will be automatically inverting the carry. What about the auxiliary carry? Auxiliary carry flag will be equal to 1 because there's a carry from the 4th bit to the 5th bit. Since there's a carry from this position to this position, you will have auxiliary carry given. What about parity? You check how many ones are there. We have 3 ones. So odd number of ones are there. Accordingly, we put the parity bit is equal to 1. We will see one more subtraction, that is the subtraction of 4C minus 6E. So a smaller number minus a bigger number. So here also you have to remember it is 4C plus minus of 6C. So you have to find the 2's complement of 6C. So 4C is 0 1 0 0. C is 12. So 8 9 10 11 12. This is 4C. Now 6C 6 4 6. E is 1 1 1 0. Now you have to represent minus 6e. So you have to find 1's complement. So 1's complement is 1, just the inversion, and plus 1 you have to add, right? So when you are adding 1, you will get it as 0 0 0 1 0 0. Now you have to add this and this one. So our answer is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, and there is no carry. So what should you do? What it does is, this is our answer, 8 9 10 11 12 13. So it is D, and this is again E, but remember you have to invert this. So carry flag become equal to